So let's set a scene. Imagine you need to get a pristine 4K video signal from one end of say, a football stadium to the other. Your standard HDMI cable from the store, it just gives up after a few meters, right? So how do the pros actually do it?
They absolutely do not daisy chain cables, I can tell you that much. No, they use something, well, something very much like what we're looking at today. The Kramer DTA-XR-IN2-F16.
It's quite a name. But this little card is basically the solution to a huge physics problem. We've got the spec sheets here, and our mission is to figure out how this thing works.
Right, because standard HDMI, it just falls off a cliff. You might get, what, 10, maybe 15 feet of a reliable 4K signal.
And after that, it's just digital snow or, nothing at all.
Exactly. So in a big venue, you're stuck.
Yeah.
And that's where this card comes in. It's an input card, a 2-channel one that slots into Kramer's big modular switchers.
And the magic word here is HDBase.
That's the magic word. It's the tech that lets you send all that data over a standard twisted pair cable, like an internet cable.
A CT6 cable or something similar.
Yep. This card takes that heavy HDMI signal and converts it. The extended reach on this thing is, well, it's the whole point. You can push full 4K at 60 hertz up to 100 meters.
100 meters. Okay, so that's about 328 feet. That gets you across pretty much any auditorium or lecture hall.
Oh, easily.
Yeah.
And if you're willing to drop the resolution down to 1080p, you can kick it into what they call ultra mode.
And that gets you?
That extends the range to a staggering 180 meters.
Whoa! That's nearly 600 feet.
Almost 600 feet. On one clean run of cable, no repeaters, no boosters, just copper.
But looking at the card here, it's not just a video extender. That's what always strikes me about HDBaseT. It's like a traffic jam of data all going down the same road. I'm seeing ports for RS-232 and IR here too.
Yeah, and that's absolutely crucial for any real-world integration. I mean, think about it. If your projector is 300 feet away, mounted on the ceiling.
You do not want to run another separate cable just to tell it to turn on.
Exactly. So this card acts as a transparent bridge. You feed the control signals in on this side, and they pop out on the other end, right alongside the video.
It also handles Ethernet, doesn't it? 100 megabits.
It does.
Wow.
So if you have a smart display that needs an internet connection for updates or content, it gets it over that same line. No need to call the IT department for another network drop.
Okay, let's talk about the audio handling, because the docs really emphasize this audio embedding and de-embedding feature. What does that actually mean for an installer?
It's a lifesaver, is what it is. It's a workflow thing. So the audio that comes in via HDMI from, let's say, a laptop.
You probably don't want that playing out of the tiny projector speakers.
You never want that. You want the big in-room PA system. So this card lets you de-embed that audio. You basically you strip it out of the digital stream right at the input.
And it gives it to you as a separate analog signal.
Exactly. You send that to your main amplifier. Or you can do the reverse. You can embed audio. Take a high-quality feed from a microphone mixer and inject it into the video stream.
So it completely solves the problem of needing all those little adapter boxes, the little audio strippers and converters.
It saves rack space. It reduces your points of failure. It just cleans everything up.
Yeah.
And because it's an input card.
It's modular.
It's modular. You only buy this long-distance capability if you need it. If your video source is right next to the switcher, you buy a simple, cheap HDMI card. If it's a camera way out in the end zone,
you buy this HDBaseT card, you mix and match.
You build the switcher you need for that specific job.
It really just drives home how much complex work goes into making these big AV systems look simple to the person actually using them.
Oh, absolutely. They just plug in their laptop, the image appears on the giant screen, and they never, ever think about the invisible plumbing inside the walls.
Or the fact that the signal might have traveled the length of 2 football fields over a single piece of copper to get there.
Right.
And it makes you wonder, as we're looking at 8K becoming more common, bandwidth requirements are about to double again. How much longer can this copper plumbing keep up? At what point do we have to start ripping it all out for fiber just to keep the pixels moving?
That is the big question, isn't it?
Something to chew on. Thanks for listening to this deep dive.